Hello, this is Mr. Wilson doing my Compound Interactions public service announcement for the community. I have been assigned two compounds, and I'm trying to come up with how they react when we pour them down the sink in science class. And then I will be making a recommendation as to if we should continue to do so or if we should find alternative methods. So let us begin. My first reactant was silver nitrate. Its chemical formula is AgNO3, and some of its distinctive properties are that it reacts with copper to form silver metal, it's toxic and corrosive, and they sometimes use it to test for chlorine because of the reaction that we're about to explore. One of its more detrimental effects is called argyria, which is accumulation of silver in the body. So if you ingest enough of this or any silver molecule, you could get staining on your skin, which we do not like. Here's my model of silver nitrate, so you can see some of the chemistry behind it, and it might help you as we move forward. Reactant 2 today is aluminum chloride, AlCl3, which is very reactive, violently so, with water and bases. It's also an irritant and a neurotoxin, which is another name for a toxin to the brain. It's actually very bad stuff that we do not want to ingest. Here's the model for aluminum chloride, which will once again help us moving forward. The reaction is that aluminum chloride and silver nitrate are both soluble in water. Basically, this means that they're going to split up into all of their ions that we saw before, into all of the individual elements when they are mixed in water, which the sink has a lot of. And when they do this, they're free to recombine with each other and kind of cross-pollinate or like mix up those ions, and they form two new possible products called silver chloride and aluminum nitrate. Silver chloride is not soluble, so it precipitates out of the solution. The first product is silver chloride, AgCl, which is a mild irritant. It also forms strong reactions with chlorine, which you can find in a lot of city water, and the powder turns dark in light. That is due to a different reaction. There's my model for silver chloride. As you can see, the two ions came together. The second product is aluminum nitrate. This is a strong oxidizer. They actually use it to tan leather. I don't know that I'd want to touch such a thing. Which is also an irritant and very flammable. Here's the very complex model for aluminum nitrate, which might help you out in understanding as well. I also have a short video that might show you this process a little bit better. So we take silver nitrate and aluminum chloride, which are both aqueous, and we actually combine them in water, and they dissociate into their separate particles, or ions. That in turn lets them freely form silver chloride, which is a solid, and the other byproduct of which is the leftovers, aluminum nitrate, which stays aqueous. So that is the basic process that it goes through. But coming back to my recommendations here, is I actually don't think any of these compounds should go down the sink. They're all either poisonous or reactive or toxic in some way, so we really need to find alternative methods for disposal. One of which I found was just contacting your local waste management center. Call them up and see where the safe disposal locations are located near you. They freely offer this information to anybody that calls them up. Here are my references. I used several different sites to accumulate all of this information and try to give you the best answer possible. Thank you for listening to my public service announcement about compound interactions.